Hi students, today in this video we're going to talk about adding rational expressions, and those are just fractions that happen to have variables in them. Okay, rational means a fraction, and when we say rational expressions, that's to indicate that we're going to have variables and kind of more complicated terms and things in our numerator and denominator. Let me share with you kind of an overview of the steps that we're going to use. Okay. This is, by the way, this is section 7.4 in San Diego City College textbook. So the first step to adding rational expressions is to find a common denominator by factoring the denominators of each of your fractions. And then we turn those fractions into an equivalent fraction by multiplying by some version of 1. Okay, so we multiply by whatever each fraction by its own version of 1. And then in step 2, we're going to rewrite each of our fractions as a fraction that is equivalent to its original fraction, because all we did was multiply by a version of 1. But now all of our new fractions will have the same denominator. Okay, that's going to be your hardest step. Once you've got that done, then we can just add or subtract our numerators because all of our denominators will be the same. After we add or subtract our numerators, then we're going to just look to see if we can simplify our fraction at all. Okay, this first example that we are going to do is right here. We've got 6x over x squared minus 4, and we're subtracting from that 3 over x plus 2. Let me just go to my whiteboard and we will work through that problem. All right, here we go. So our problem is 6x over x squared minus 4, and we're subtracting from that 3 over x plus 2. Okay, so our first step is kind of a complicated step. We have to figure out basically what the factors are of each of our denominators so that we can figure out what the version of 1 is for each of our fractions that we need to multiply by to make our denominators look the same. Okay, that's our finding the LCD step. So the first thing we want to do is factor both of our denominators. And you notice we've got kind of a little more complicated thing going on. We've got an x squared minus 4. So this has two separate terms, the x squared and the negative 4. So we have to factor this like a binomial. And binomials really only factor in a couple of ways. Here we've got what's called a difference of squares situation. So the x squared minus 4 is going to factor into an x plus 4, or sorry, an x plus 2 and an x minus 2. Okay. Make that guy look better for you. Okay. So those are our two factors here. Okay, so really you want to understand what is a factor and what is not a factor. This thing in parentheses, this x minus 2, that's a single factor there. And this x minus 2 is a single factor there. So we've got two factors to this first denominator. X plus 2 is one of our factors, and x minus 2 is another one of our factors. Okay. Then when we look at our second fraction, our denominator is x minus 2. And actually x minus 2, or sorry, x plus 2, sorry. X plus 2 can't be factored any further. So it is already just one single factor, x plus 2. Okay. So if we want we can rewrite our fractions right now in this factored form. And sometimes it's nice to just work through with your denominators in factored form the whole way, because we're going to need our denominators to be factored when we get to step 3, where we try to just simplify our final rational expression. Okay. So let's go ahead and do that. We've factored our denominators. So I'm just going to rewrite this original problem. We've got 6x over x, 6x over our x plus 2 times x minus 2. All right, that's our first fraction. And our other fraction is a 3 over x plus 2. And I just put it in parentheses there to really reverse that this is a factor. Sometimes to use parentheses around every factor so that you can really see how the factors are broken up and you don't get confused with all the pieces inside, like the x plus 2s and x minus 2s, right? These are just chunks. The parentheses are representing important chunks. And now we don't really need to think about what's inside those parentheses too much. Okay, so I just rewrote my fractions in factored form. And now I have to figure out those versions of 1 that I need to multiply each of them by. I can see that my first denominator actually has all the factors that are contained in my second denominator, right? The second fraction has only a single factor of x plus 2, and I already have that factor in my first fraction. So I don't need to multiply this first fraction by anything, okay? But my second fraction only has a factor of x plus 2. It is missing this factor of x minus 2. So I need to multiply this first fraction by a factor of x minus 2 over x minus 2. And make sure you use parentheses here, okay? That whole thing, x minus 2, is one chunk, and it's going to get multiplied by everything in our numerator here, okay? So you're going to have to distribute. Everything in that numerator is getting multiplied by everything in the x minus 2 that we're multiplying by, okay? Because essentially we're multiplying by a whole second fraction here. Okay, so this guy in green, remember, is just to 1, right? This whole thing in green is really just 1. So we're really just multiplying this section by this version of 1. Okay. Once we do that, we can rewrite our expression. So this whole thing is going to equal, we've still got our 6x over x plus 2 times x minus 2. Okay. And then our second fraction now is going to be our numerator. We've got a 3 times an x and a 3 times a minus 2. So our numerator here is going to be 3x minus 6. And our denominator is going to be x plus 2 times x minus 2. All right. And so now we can say, yes, we did multiply by the correct version of 1 because our new fractions both have the same denominator, which was our goal, so that we can add them together. Now that our denominators are the same, we're going to write a single fraction that has the same denominator. And as the numerators, we're just going to do our subtraction step. Okay, so our subtraction step is going to have us doing 6x minus 3x minus 6. But what's really important to notice here is that we are subtracting the entire 3x minus 6. Okay, if you guys remember PEMDAS, parentheses, exponents, whatever. Part of that parentheses, sometimes they also say parentheses and fractions and grouping symbols. So a fraction is a grouping symbol. We don't put parentheses around all the tops and bottoms of our fractions, but it's inherently understood that they are there. So when we are subtracting this fraction, we are subtracting the entire 3x minus 6. So when you combine your two fractions, it's really important to throw some parentheses in there, right? We threw in some parentheses up here. It's nice to throw in parentheses when you know that they belong there, to reinforce in your mind that this is a grouping, okay? So what does that leave us with? We've got 6x minus our 3x minus 6. All over that single denominator, x plus 2 times x minus 2. Okay, and now you can see when we write this as a single fraction, see how the parentheses here are going to make a difference, because this negative sign is going to get distributed here, right? So it's not really going to be a -6. We're going to end up with a minus -6, which will give us a positive 6. So knowing these parentheses makes the difference of this second term being added or subtracted. Okay. So now we can do that. 6x minus 3x is going to give us 3x, and minus -6 is going to give us a positive 6. All right, so what we end up with is a 3x plus 6 over x plus 2 times x minus 2. Now remember, we have to do our last step. Step 3 is simplify. So let me move to one more page here. Remember what we've got. We've got a 3x plus 6 over x minus 2 times x plus 2. Okay. Now, the denominator here is factored and contains two factors. X minus 2 is one of them. X plus 2 is one of them. The numerator is not factored. It contains two separate terms that are being added, right? And so if we want to cancel out anything in the numerator and the denominator, we have to factor that numerator. To factor that numerator, we have to look at our two separate terms, which is our 3x is one of those terms, and our 6 is another one of those terms, and ask ourselves, do they have any common factors? And indeed they do. They have a multiple of 3. So we can pull out that multiple of 3 from the 3x, and we can pull out that multiple of 3 from the 6. Okay, right, because this 3x is 3 times x, and this 6 is 3 times 2. So a factor of 3 out of both of them. Now we are over x minus 2 times x plus 2. Now in our numerator, if you want, you can put parentheses around that factor of 3 just to reinforce for yourself that 3 is a factor of the numerator now. You don't need the parentheses, but it just helps reinforce it. Now I can see I've got all these factors on the top, which are all the chunks being multiplied. I've got a factor of 3 and a factor of x plus 2. On the bottom, I've got a factor of x minus 2 and a factor of x plus 2. Now that everything's in completely factored form, we can cancel out the common factors, right? And we're left with just a 3 over x minus 2. So that's how you add and subtract rational expressions. It's the same steps as before. It's just adding and subtracting fractions. It's just that the factoring is a little bit trickier because some of your factors might have more than one term. So use your parentheses to really see how your factors are grouped. And make sure you're very careful that you are factoring this last step that we just did before you do your final simplification step.